Hi there, this is Jacob Nash, Engineering Lessons. This is Unit 2.1, Lesson 15. This is the final lesson, likely the longest lesson of Unit 2.1. Now, I'm solving for Activity 2.1.7, but I am only doing the long problem where you're solving for the truss. I'm not doing 1, 2, or 3. I'm only doing 4, and I'm not doing the conclusion questions for time's sake. But in the description, I will have a document so you can see the answer to those. So click on that if you need the rest, but that's just because this is going to take forever, and I couldn't do that. So here we're going to solve for the truss, and there are lots of steps we need to do in order to do that. We're eventually going to find the internal and external forces and determine if they're tension or compression forces. We will do these 5 steps over here to do that. First, we need to see if the truss is statically determinate. To do that, we use the equation 2J equals M plus R. So, how many joints are there? There are 4 joints. Here, 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 and here. So we can add in 4. How many members are there? Here's 1 member. Here's 2 members, 3 members, 4 members, and 5 members. So we can say 5 plus how many reaction forces are there? So we see a pen support, that is 2. That means there's 2 reaction forces there. And for the roller, there's only 1. So that means 3. And that turns out to be 8 equals 8. And yes, that's true. So it is statically determinate. If it wasn't, then you could not solve the problem anymore because that would make everything else false. That's probably what you want, I bet, because then you wouldn't have to do all this work that we're about to do. But now we need to find the external reaction forces. We said there was 3 because of the roller and the pen support, but what are they? Well, remember back from the last lesson, I said that there's a X and Y force for the pen and only a Y for the roller. So let's erase these 2 supports and replace them with the labeled forces of what they are. Because this is joint B, we're going to call the forces FB, X, and Y. So there's a FBX force right here. I'll have to do this because I can't fit it right there. FBX, and then up is FBY. Always, here's a rule. External reaction forces point towards a joint, but member forces point away from it. So that's a rule. That's why they're pointing towards it. And then there's only one force for the roller, where the roller was, and that's only a Y force, so that's FDY. Since this is joint D, we'll say joint DY, and Y because it's pointing up. That's not the only thing we have to do, though. Just because we know what we can call them doesn't mean we're done. We actually have to find out what values are FBX, FBY, and FDY. So, since those are the external forces we're going to find, let's write them here. FBX, FBY, and FDY. What will they equal? Let's find out. So what equations we can use to find these things are the sum of the x forces equals 0, the sum of the y forces equals 0, and the sum of the moments equals 0. These are what we can use. Oops. So let's see what we can do. What are the x forces? The only x force we have is this one, FBX. So FBX must equal 0. That's easy. We already found that one. And it will be pounds of force. Why? Because of that up there, that unit. Then we need to find the y forces. So the sum of the y forces equals 0. So that means FBY plus FDY must equal 0. But there's actually another y force, the one that we were given originally, 300 pounds. That's a y force because it's pointing down. So we have to add that. And because it's pointing down, we have to make it negative. So let's take away this. And I know that there's not a lot of space here, but let's try to do this. Minus 300 equals 0. Well, we can add 300 right here. But that doesn't do a whole lot, because then we just get FBY plus FDY equals 300. That's not useful because we don't know either of those. So what do? Well, when solving for a truss, if you ever come into a point where you can't find the something and it seems impossible, you need to go to the next step. So we need to find the sum of the moments. So since we're out of room, we will erase this. Since we already found the sum of the x forces, we will erase this. And we will right over here, sum of the y forces equals 0. And then that FBY plus FDY equals 300. And then I'll erase this. And we'll come back to that. So what can we do for the moment forces? Well, what we need to do is think about the way that the triangle truss would rotate, because remember, that's what a moment means. If it was rotating around joint B, which is what we're thinking of right now, it would go clockwise. Because this force is down, so it would go like this, clockwise. That means that we need to make this force negative. So we say negative 300. Now what? We need to multiply the negative 300 by how far it is away from the joint. 1 foot, it says right there. Then now we need to add FDY, because that's the other moment. And it is positive, because if this truss rotated around this point, it would be counterclockwise, because this force is down, and counterclockwise means positive. And we need to multiply that by how far away it is from the force. That actually is going to have to be 1 plus 4. which is 5. Now, we're really running out of room here. I don't know what to do. Let's try to write this. Oops, thought I was on eraser. We will write this down over here. So we had negative 300 times 1 plus f dy times 5 equals 0 because of this equation. Now we can, negative 300 times 1 is just itself. We can add 300 to both sides, and then we get this. We get 5 f dy. So we just moved the 5 to make it a coefficient of the f dy equals 300. We can divide by 5 then, and we get that f dy equals 60 pounds of force. Yay, we found another one. After all that work, we finally found another external force. So remember, our final goal is to find all the external and internal forces. Right now, we're just on the second step. We need to find FBY now. Now we can. Going back to this, that feels like that was ancient times, but we need to go back to the sum of the y forces equation and add that. So that means FBY plus 60, we're substituting FDY, equals 300. Subtract 60, and you find out that FBY is 140 pounds of force. Yay! We found all the external forces, and now we can move on to the third step. So, let me check this off. And now we need to find the angles. Typically, you need to find 2 angles, but luckily, they gave us one of those for this time. So now we found there's 75-degree angle, but we still need to find this angle right here. How do we do that? And for one thing, why do we need to do that? We need to do that because to find the internal forces, we need to know the angle measures. So here is what we do. We need to find angle ADC. ADC. We can take this triangle and move it over here and pretty much cut it in half. So it's a right triangle. We are trying to find this angle. This measure is 4. This is also 4. See, because of those two. And then we don't need to know the hypotenuse, but we'll label it. This is H, hypotenuse, to the angle. This is adjacent, and this is opposite. How can we find the angle measure? We can use this doing SOHCAHTOA. What do we use? Sine, cosine, or tangent? We have to use tangent because the 2 measures we know are the opposite and adjacent, TOA. We don't know the hypotenuse, so we can't use sine or cosine. So now we can use our equation that we know, and that is that the tangent, you might not know this, I don't think I've mentioned this in a video, the tangent of an angle, theta, equals opposite over adjacent, which is 4 over 4, and we want to get the angle by itself. To do that, we have to get rid of tangent. We can do that by taking the negative first of it. And after we do that, we find out that angle ADC equals 45 degrees. So, 45 degrees. There we go. We found the angle. Normally, we would find 2. you would do the same thing to find the 75-degree angle if it wasn't there. Now we did that. Time for the fourth step. Internal forces. This is the longest step. If you thought this one was long, this one's even longer. I told you this was going to be the longest lesson. Now we need to find all of the internal forces, which mean the forces of the members. So we said there was 5 members. That's how we found out that it was statically determinate in the first step. But what are they? There is FBA, that is this. There is FBC, that is this. There is FAC, ooh, I meant to do blue. FAC, that's this. There is FAD. F just means force of, and it's called AD because of the joints that there are. That's this. And then the last one is FCD, which is this. Okay, that means those are the five internal forces: FBA, FBC, FAC, FAD, FCD. So in order to complete this step, we need to find all 5 of those. How? That's the question. Well, we can start off by drawing a free body diagram of each joint. We won't need to do A. We only need to do B, C, and D because those are the only places where forces are applied at that point. So let's start out with point B. What are the forces? Well, we already have 2 forces that are the external forces. They're drawn towards. So that is FBX and FBY. We have also this force, FBA, to the northeast direction, drawn away because it's an internal force. And we also have FBC, that's to the right, drawn away because it's an internal force. Those are the 4 forces. We can use the same equations that we used for external forces to do this. We'll start out with sum of the X. So, sum of the X forces. That means all the ones that have X that are pointed to the left or right are going to be added and set equal to 0 in order to find them. So take a snapshot of let's first say that what the X forces are. This one, FBX, FBC, but also FBA because it's slightly pointing to the left. So we only need to get the X component from that. How we do that is we need to use the cosine. And that's because of the way that's pointing. We use the cosine of the angle 75. That's why we needed to find the angles. So take a snapshot of that, and I'm going to erase that so that I have more room to write. So we're adding the X components. The first component is FBX. The second one is FBC. And the third one is FBA. But we need to multiply it by the cosine of the angle, which is 75 degrees, and set that all equal to 0. The only thing we can solve for so far is the well, we know FBX is 0. We already found that out. That's right here. FBC, we don't know. FBA, we don't know. Wait a second. Oh, yeah, we don't know. We don't know it. And cosine of 75, we could know it if we solved for it, but we're going to leave it like that for now. We can't do anything. Remember what I said, when you don't know something, you move on to next step. We need to now do that y components. The only y component, remember, we had force here, 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 and here. This is the only y component, which is FBY, which is the internal force. FBY, we already found that. That was 60 pounds of force. That's not the only y component. I'm sorry that I just said that. I didn't mean to say that. There's still FBA because it's pointing up and to the right. So we need to do the sine of it this time because we're getting the y component. We need to do sine. So 60, because that's the FBY, plus the FBA, which is the times the sine of 75 degrees equals 0. The sine of 75 degrees, we aren't going to solve that. We're going to divide by it. Wait a second. I'm sorry. FBY. I messed that up. Hopefully you caught that. That's actually 240. We actually would subtract first. And so we subtract 240 and then divide by sine of 75. After you do both of those things, you get that FBA is negative 248.5 pounds of force. Yes, there we go. We found our first one. There we go. Now we can plug this in up here. We can come back to this now. We'll erase this and continue. We now can continue to solve this. What we can do is add, since this actually right here is going to turn out to be negative, so we'll just do that. And we add 248.5 to both sides. Then we get, this just goes away because it's 0. So we just get FBC times the cosine of 75 equals 248.5. Divide by cosine of 75 on both sides. And since we're pretty much solving for FBC, we get that, I'll say it after I erase this. We get that FBC equals 960.1 pounds. We found our next internal force, sorry. 961.1. Or sorry, 960.1. That was, so remember, we drew a free body diagram of joint B. Now we have to draw one of point C in order to find some more forces. So we have up FAC, that is this, and we also have this and this that are drawn to the side of it. That is FBC and that is FCD. Or sorry, BC. Wait a second, what in the world? Yeah, CD, I don't know. I got confused for a second. And remember, we are going to find the ones that we don't know. So we need to do the sum of the x. The sum of the x. Well, for this one, the only ones that are in the x are FBC and FCD. So they need to be added together to equal 0. We already found FBC just a minute ago. That's 960.1 plus FCD equals 0. We can subtract 960.1 and we get that FCD is negative 960.1. Wait a second. No. I'm sorry, I must have messed something up. Oh, yeah, I know what I did. I'm sorry. Because this is pointing to the left, it starts out as negative anyways. So we actually add to both sides, which would make this positive. So it's the same thing. FCD is also 960.1 pounds of force. And here's a hint. That's the case because they are both equally far away from joint C. That's why. So now we can do the sum of the y forces for joint C. The only y force is FAC, if you notice. So if the sum of the y forces equals 0 and there only is one force, that means FAC equals 0 because there's nothing else to add it to. So that's just 0 pounds of force. We only have one more to find, FAD. That's the only one left, and then we're done with the internal forces. We now need to draw a free body diagram of joint D. Now, free body diagram is FBD. On some problems, that actually might be a force you have to find, so don't get confused with that. But that's not the case for this one. So, for this, these are the two forces that there are, three forces that there are. FDY from the roller, and then FCD and FAD. So let's draw those. We have FBC to the left, FAC or FAD to the northwest, up left, FAD, and below, or no, not down, up, because it's an external force, is FDY. Now, we need to find FAC, or D, sorry, I actually wrote that. We need to find FAD, and remember when we're trying to do, when we're trying to find a diagonal force, we need to know the angle, but it has to be relative to the positive x-axis. This is the negative x-axis. Even though we know 45 degrees is right here, that's the negative x-axis. This would be the positive that's kind of non-existent. How can we find that? Well, we know that this full angle is 180. So we need to subtract 45 from that to get 135. 135 degrees of that angle. So that's what angle we'll use in a minute. So we need to find the sum of the x forces first, like we have been doing. The x forces are, there's only two. FBC, we found that was 960.1 plus FAC, or D, sorry, FAD times the cosine, because we're finding the x component of 135 equals 0. we first subtract 960.1 to both sides, and then we divide by cosine of 135 after that. I'm just not doing that because of lack of space. And after we do that, we find that FAD is, what was it? Negative 1,357.8 pounds of force. And we're done with the internal forces. We don't have to find the sum of the y forces because that is only FDY, and we already found that, 60 pounds force. So let me try to get this in here. Pounds of force. And we're almost done. Oof. Okay, sorry, that's very messy. So, in case you can't read my handwriting, the external forces are 0 for FBX, 140 for FBY, 60 for FDY. And for the internal forces, we have negative 248.5 for FBA, 960.1 for FBC, 0 for FAC, negative 1,357.8 for FAD, and 960.1 for FCD. That's our forces. So we've done step 4. Step 5 is very simple. Are they tension or compression? I don't think we talked about this in the last lesson, but tension forces mean that something is being pulled. Compression means it's being pushed together. All of the tension forces are going to be the positive forces, and the compressions are going to be the negative. So I will, in red, I will underline the tension ones, and in green, I'll do the compression. So tensions are the positive ones, so that's FBC and FCD, because they're the same thing. And then negative ones are FBA and FD, or AD, which are the compression forces. FAC is 0, so it's neither a compression or tension force. And we're not doing the external forces, that's only for the internal. And we check off the final step, and we are done. All that work, I have no clue how long this video has been, but all that work, it paid off because we got the problem right. And that took a very long time for me to do, as you could see, but it should take you less time because you don't have to explain. You only have to do it. And you don't have to erase and a whole bunch of stuff. That's why it took a long time for me. And remember that this is activity 2.1.7. The rest of the questions are going to be in a Google Docs in the description. I'll post a link there. And that is it for unit 2.1. This is a unit that lasted nearly a month. But if you're watching during when I publish this, which is December, have a great Christmas, and I wish you good luck on your test. And I'm not sure, there are more units for Principles of Engineering. This may be the last one I do, so if it is, then I wish you good luck on your exam as well. So thank you for watching my videos, and that will be it.